Hello everyone, hope you're doing and welcome back to my channel. Today we are at day 19 of the February daily LeetCode challenge and we again have a medium question, and let me tell you this very frankly, insider info. Here we are following a series on backtracking, okay? And again, this is one of those questions where we are going through the backtracking approach, okay? And if you have been following the previous videos, I'm sure by now that this question you will find very relevant, because in the previous questions, especially in the yesterday's question, we have seen how to dodge questions which are related to backtracking, as well as which involve a sorting which involves especially the lexicographical sorting, okay? So this is one such question where we are having the backtracking concept and we are having a sorting involved, which is actually lexicographical sorting, okay? So what is lexicographical sorting? I've been explained this in multiple videos. One such scenario is this, okay? See this case. I'm just like taking some time to see. I'm assuming that you have already gone through the question, okay? And then if you are coming to this video, I'm trying to explain all the basic aspects involved, and then we'll go to the harder part, and then we'll see how to optimize it in the best way possible, okay? Now see here, just let me quickly explain what is lexicographical sorting. See, this is your string one, this is your string two, okay? See this case, based on the first point of difference, it is decided which string is smaller, okay, when we are seeing the lexicographical sorting, okay? So see, in this case, the first point of difference comes here, okay? This is B, this is C. So since B is smaller than C, we'll say this whole string is lexicographical smaller than this particular string, okay? So in the lexicographical sorting, this string will come ahead of this string, okay? Just a second. Yeah, this thing will come ahead of this thing, okay? Remember, in the first point of difference, if you see the second point of difference, this is a C, this is A, so this should have been sorted. But again, we will not go for the second point of difference, we should always go for the first point of difference, okay? Now, how to, let's come to now this question. See, I'm assuming you have already gone to this question. I'm just highlighting some important points here. First thing is, we have to only ensure our string consists of ABC. Second thing is that no additional value should be same, okay? Third point is that, see, they have given some examples of the happy strings. You can go through them. Again, they're trying to say the same thing. No additional value should be same, okay? Now, after that, they are, see, previously in all such questions, what we've done is either we were asked the lexicographical smallest or we were asked the lexicographical largest, okay? In this case, it is slightly different. They are basically asking you, for example, let us say you are having all the lexicographical strings and sorted away, then they're asking what is the case string in that, okay? You have written the case string in that, okay? That is the basic thing here, okay? So you would have to, like uh, we have to go to a level where you don't have to just find the smallest and the largest, but you have to also find the kth, okay? Based on the ordering, lexicographical ordering, or find the kth, okay? Now, the other part is that, see, this is edge case, okay? This is a opportunity for you to improve your code, to optimize your code, okay? They are saying that if the kth string doesn't exist, okay? If the kth string doesn't exist in this ordering, then you have to ensure that you are returning an empty string, okay? We'll see this case also, but remember, this is a place where you can optimize your code, okay? Where you can go ahead of others, because many people will not be handling this kind of cases. What they will do is simply they will ensure the answer is equal to 0, okay, like this. They will just initialize answer equal to empty, and then they'll write some code. Ultimately, if let us say their code, like, say, they will generate all the cases, and finally, since none of their cases are reaching that particular k, so they're writing empty, okay? They're writing the correct value, but remember, you are generating all the cases for that, okay? You're generating all the strings for that, just to calculate, to get to know that, okay, this is not even possible. So we will try to avoid that. With a single calculation, we can get to know if k is even possible or not, okay? Kth value in this particular for given n is even possible or not, we'll see that, okay? Now again, yep, as you can see, for example number one, k length is 1 and k equal to 3, okay? So these are the various possibilities. Among them, the third value we have to return, okay? This is edge case, we'll come to this, okay? Example number 2 edge case, we'll come to this. And yeah, for n equal to 3, there are 12 possibilities. As you can see, there are 12 such possibilities. We will have to return the ninth one, okay? So this is the ninth one, we'll have to return that, okay? Now let me quickly explain how we're doing the calculations. See this case, let us talk about n equal to 3, okay? Now, see, I've written 4 places. Okay, these are like placeholders. You will have to, place some values. Okay, among events, you have to place something. Okay, this can be filled in 3 ways. This will have to be filled in 2 ways. Why 2 ways? See, whatever you write here, okay, among ABC, whatever you write here, that you cannot write here. Okay, because it would have repeated. Okay, it will violate this condition. Remember that it will violate this condition. Okay, for that reason, if you write anything about ABC here, this place you will be writing only. You have only 2 possibilities. Okay, let us say you are writing A here. Okay, so you cannot write A here again. You have to write either B or C. Okay, so you have 2 possibilities. Okay, so that is what I'm trying to say. This place has 3 possibilities, this place has 2 possibilities, and any place after that, okay, any place after that will have 2 possibilities, because you have to ensure that whatever value is here, that should not be repeated here, okay? As simple as that, right? Now, if you consider the same way, can you quickly tell me how many strings can we generate if n equal to 3? It is going to be the multiplication of 3 into 22, which is 12, okay? Which is 12. So can you now tell me for n equal to 4, how many strings can be generated? Same thing you have to do. You have to just multiply additional 2 now, and you will get 12 into 2, which is 24 now, okay? Same thing we'll have to do. So can you find a pattern here? Can you relate this pattern with n? See, what is happening is there is only one 3, and rest all of them are going to be 2, okay? So there are how many twos are there? There are going to be n minus 1 twos. Okay, so it is going to be 2 into 2 into 2 like that for n minus 1 times. So it is going to be 2 raised to power n minus 1 into 3. Okay, so that is what we have done here. If you see, we are doing 2 raised to power n minus 1, okay, into 3. This will tell you the number of strings that are possible. Okay, if k is greater than that, then we'll have to return an empty string. Remember, because of this, what we are doing, we are not doing any simulation, any like generation of permutations and all that. With just a single calculation, we are getting to know if we have to even generate strings or not, if it is even possible or not to achieve k. Okay, and thus we're returning empty string. Okay, now let me quickly show how I'm doing the sorting. Okay, see, as you might have seen in my previous videos, what I'm doing is the way in which the strings are generated in my solution, they follow the lexicographical ordering. Okay, that means whenever I reach the kth string, I am going to return the answer directly. Okay, that is where I'm starting the pruning. So if you see example number 3, once I read CAB, okay, which is the ninth string, I will stop all my calculations from there on. Okay, I will not generate anything else. Okay, apart from that. Okay, now see, so what I'm using answer which is empty string. This is going to see, this is the L underscore order index. This will tell me the order, that is the, let us say I'm generating a string, that string is in which, like in the lexicographical order it is present which index. Okay, that will, this particular value will tell me that. Okay, currently it is 0, like when the first string is generated it will 1, and then it will 2 and so on. Okay, so when this value becomes equal to k, that means we'll get to know that we have reached our answer. Okay, now these are the letters that we have to use to form all our strings, right? So this is the recursive function. What is the recursive function? Recursive function is something that is calling itself, okay, inside it. So as you can see here, we are just passing as. Okay, then what we are doing, see, we are declaring everything that is referred outside from outside is non-local. See, this is the stopping condition. Remember, in every recursion, whenever you're doing recursion, the first statement in your recursive function should be a stopping statement. Okay, a base condition. So whenever the string reaches a length of n, if you have to stop. Okay, I am just incrementing this because the way in which I have implemented, I will always get the answer in a sorted way. Okay, in a lexicographical sorted way. So always I will increment this by 1. Okay, then if this equals to k, that means we have reached our answer. If the order, okay, of the index of the current string is equal to k, that means we have reached the answer, and length of answer equal to 0. See, this is just to ensure we do not overwrite. Okay, we do not overwrite. So whenever this, see, it is not needed, I agree, but just as an extra step, because in my previous videos I have shown you this, so I've just added it so that you can find it familiar to what we have seen previously. Okay, I agree this is not needed in this case because this condition will be always unique. Okay, so whenever it is equal to k, we are reaching the answer. We will just store our answer as in equal to answer. Okay, this will be stored here in this global variable, and then we return true. So whenever we return true, we'll see the in the further cases. Whenever we return true, we are going to prune all our existing branches. Okay, all our recursive branches which are open, we'll start pruning them. Okay, I will tell you that how it works. But remember, this is a significant optimization. Okay, in all such cases, let us say this doesn't happen, we will return true. Okay, whenever the length s equals to n, either we will return true or we will return false. Just remember that, but we will not proceed further. Okay, so this is going to be acting as stopping condition. Okay, for our recursive function. Now what I'm doing, see, for every I in the same order I'm following. Okay, for every I in the same order, what I'm doing, see, if the last inserted value in s is not equal to I, that means, remember, we have to follow this condition, right? The last inserted value should not be equal to I. Okay, if that is the case, then yeah, go ahead and do a recursive function call. In the recursive function call, what you are passing, see, whatever s is that I'm using, and just adding I. Okay, I'm just appending I to the s, and then I'm making the function call. If this function call returns true, that means we have reached our answer. We need not do any further exploration. So remember, there is just iteration going on. There could be further iterations. Okay, let us say we are in iteration number 1. There are two more iterations to go for. Okay, but if we get this returns function is recursive function call returns true, that means start the pruning operation. Okay, here also we return. Remember, this is not a break statement or a continue statement. We are returning directly. That is, we are going out of this function now. Just understand the impact. Whenever this equals to true, we will start backtracking. Okay, so there might be some iterations left in this, but we will not bother about that. Once we reach the answer, we will backtrack. Okay, any further iterations left, we don't bother, we simply return. Okay, we are returning for true. So we will just break out of this and return true from this function. Okay, so if this whole function executes and we have not written the return statement, finally we will return true. Okay, remember, this code should be unreachable based on the context that we are using and based on the inputs that we are getting from the test cases. Okay, this should be unreachable code. Okay, yesterday's code also I have shown you, this is a kind of unreachable code. In Java, when you're trying to convert this code in Java, what you have to do is, see, in Java always you have to see, whenever you return type is boolean, you have to return something, right? For that reason we are writing this, but again, this should not be reachable. Okay, within this you should be able to get it true. Okay, now, so this is our recursive function call. Okay, this is done. Now I will show you where we are calling this function starting. Okay, see, for I letters, this is going to the first function called C. If, see, this is the function call. See, remember, here we're doing s plus I. Here we are just passing I. Okay, so this is going to the first letters of our string that we're forming. Okay, it is going to start with I. Okay, in this order it will be going. First all letters, that all strings starting with A, then with B, and then with C. Okay. So yeah, we are making this functional call. Same thing here. If it runs true, we will simply return the answer. We will not bother about which iterations are left and all that. We will simply return the answer if the return statement is true. Okay. This ensures that we do not go for any cases which are unneeded, which are not needed at all. Okay, which are unnecessary. So returning true, again, this is going to be a such statement where we will not go ever. Okay, this is unreachable code. Okay. Yep. So this was my code, and I have given a detailed tracing for the example number 3. You can go through it, and in my logs also, like I have done a lot of work here. Okay, here also you can go through. Okay, currently I have hidden all the print statements, but if you want, you can like uncomment them. You can start exploring them. Okay, so yeah, that was all for this particular video. This was my 120th video. Okay, 120th video of continuous lead coding. Yep, there are many more days to come. I hope you are enjoying my videos. I hope you're getting to learn at least something new. I always try my best to get the quality content for you. But again, you may be lacking, you may not be lacking. But again, at least there is something that I am getting. Okay, at least I'm getting the feeling that okay, someone can learn from me. Okay, those who cannot buy paid courses, they can at least get some quality content from my videos. That is the objective with which I am working. Because of this objective, even I am getting a reason to code every day. That is helping me. Okay, a lot. So yeah, that was all for this video. If you like my content, please do subscribe. Your single action of subscribing will ensure that this video goes to multiple more students who may not be able to afford costly courses. For them, maybe this itself could be a lot of this could bring a lot of motivation. They can get a quality content by this kind of videos. Okay, they will get every day, they will get a quality content like this. They will be getting solutions like this, because of which they can learn further. Okay, from free sources they can learn. They just need an internet connection. So if you subscribe, this will ensure that this kind of videos go to multiple more people who may not have access to paid resources. Okay, this can act as their source of learning. So yeah, that was all for this particular video. See you tomorrow. Thanks a lot.